Okay. So, now what FBS constant said that at k equal to 0 n minus 1 w omega minus 2 pi by n into k must be equal to a constant which is n omega 0. So, it expressed that suppose this is my you can say this is my filter response, this is W, this is W n. Okay. So, this is n W and I have taken a analysis window which is n. So, n W is less than analysis window, so it is satisfied FBS constant, and it is said that the summation of filter response. Okay. So, if the this is the frequency scale. So, this is omega, this is my filter frequency response, this is my filter frequency response. If this is the frequency response, then I can say the frequency response, this is 2 pi by n. So, there is another filter, this is 2 pi by n into 2 into 1. So, summation frequency response of the analysis filter should sum to a constant. So, if I sum it, it should give me a constant which is nothing but a n into W0. Okay. So, what is the FBS constant? That analysis window must be less than the length of the DFT or number of channel. Okay. Then go for the generalized FBS method. Now, I do it generalize the FBS method. Okay. So, this I have analyzed with the FBS method with filtering view. Now, let us try to generalize this FBS method. So, what is generalization said? So, I can say xn is recoverable inverse Fourier transform. So, this is 2 pi, let us inverse Fourier transform, I am not taking DFT. So, it is same analogy is same. So, minus pi to pi, okay, minus pi to pi, then frequency response. So, I can say m or r equal to minus infinity to infinity. I define that f of n minus r x of r omega e to the power j omega n d omega. So, where r is the dissemination in time, r is the shifting of the window. So, first shifting, second shifting, third shifting. So, this is r, this is 2r, this is 3r. Okay. So, this is the dissemination in time r. So, f of n minus r. So, I can say smoothing function f of nm is the smoothing function, time varying synthesis filter. This is called time varying synthesis filter. It can be shown that any f of nm that fulfill the condition below make the synthesis equation above valid. So, this is xn if this multiply by the analysis window, f of n minus m into Wm is equal to 1, where m equal to minus infinity to infinity. Okay. So, in FBS basic FBS method, the method can be obtained by setting the synthesis filter to a f of nm. I have said it is equal to delta function, delta m. Okay. Now, so consider a discrete, now I consider a discrete. So, consider the discrete STFT of distribution factor L. Okay. Forget about this part. Let us consider I have a signal and I shifted the frame with factor L. So, dissemination time dissemination factor is L. Okay. So, I can say y by n after I take the IDFT is nothing but a L by n into r equal to minus infinity to infinity and k equal to 0 to n minus 1, n is the DFT length, f of n r n minus RL, okay, into x of RL k e to the power j 2 pi by n into nk. So, I said L is the dissemination in time. So, if it is n equal to nothing but r into L, so r equal to 1 first shifting, r equal to 2 second analysis window, r equal to 3 third, fourth, fifth, that is what I will get. So, I replace that R L. Okay. So, time varying smoothing function, let us f of nm is nothing but a fm. Let us f of nth time m number of sample, m is the number of sample, let us is equal to fm. Then I can say f of n minus RL is nothing but a f of n minus RL, that time is shifting. Okay. Then I can write down this equation, instead of this one I can write f of n minus RL. So, these equation hold only following constant is satisfied by the synthesis, analysis and synthesis filter as well as the temporal dissemination frequency sampling factor when L into this function. So, I can say this is satisfied that yn is equal to xn when L into infinite of r equal to minus infinity to infinity f of n minus RL multiply by W RL minus n plus Pn is equal to delta P for all n. So, Fm is equal to delta n, if the Fm is equal to f of m is equal to delta n and L is equal to 1, this satisfies. If Fm is equal to delta m and L is equal to, so sample by sample recovery satisfy. So, FBS method, so this is satisfied by FBS method. So, generalized FBS method, if L is greater than 1, then Fm is an interpolating filter. So, Fm is delta m only basic FBS method, but if Fm is, if it is Fm is delta m, then the consideration is the time dissemination L should be 1. Dissemination factor in time L should be 1. If I want L is greater than 1, then Fn is an interpolating filter. So, FBS method, if I consider the synthesis function or smoothing filter is delta function and L equal to 1, then FBS method I can recover the signal. But if I want L greater than 1 in FBS method, then Fn is an interpolation filter. So, helical interpolation and weightage overlap add method based interpolation, that is there. So, FBS constant is that FBS says that analysis window size NW must be less than equal to length of the DFT. So, if I use let us 20 millisecond window which is 320 sample, okay, in that case my the DFT length should be more than 320. So, 512, if I take n equal to 512 and the window length is 20 millisecond, that is fine, no problem, I can completely recover is possible. Okay. Another method of synthesis is that overlap add method. So, this is another method of STFT synthesis, this is called overlap add method. So, in overlap add method, so take inverse DFT for each fixed time of the discrete STFT. Instead of dividing out the analysis window from each of the resulting short time section, I can do a add operation. So, what I said that take the window, analyze it and take the inverse transform, then what you get? You get the signal divided by, if I want to get back the signal, then what I required that Xn has to be Fn divided by W0. But instead of division, what I do, take one and take another one in here and overlap and add them. So, overlap add operation effectively eliminate the analysis window. So, what I am doing, instead of dividing by the W0, I take the overlap analysis window and this overlap if I add them, so due to this overlap addition, this effect of analysis window will be removed. So, if Xn is the average over many short time segment, instead of normalize and normalize by W0, then Xn is nothing but this one. Okay. So, I am not mathematics you can see from these slides. So, where W0 is equal to Wn give by this one. Okay. So, I can say let us Yn, what is the Yn in overlap add method? Yn is equal to 1 by W0 into P equal to minus infinity to infinity. So, all segments I sum up x of n into W P minus n. Okay. So, I can say it is nothing but a x of n divided by W0 into P of minus infinity to infinity W P minus n. Now, if I say Yn is equal to Xn only if this part is equal to W0, or I can write capital W0. Here W0 is not the zeroth sample of the window. So W0 is nothing but a n equal to minus infinity to infinity Wn normalized. So this is the average, or you can say the first component of the Fourier transform where k equal to 0. So DC component, which is nothing but the average of all sample. Average of all sample give me the DC component. So here this should be equal to W0. Okay. Now if it is W0, so sum of value of square, some sequence. So this is obviously sum of sequence is nothing but the first Fourier transform. Okay. So let's dissemination time is L. Instead of shifting sample by sample, I shifted L sample. So it is nothing but a p equal to minus infinity to infinity W p into L. I shifted L length minus n, which is nothing but a W0, capital W0 divided by L. Okay. So instead of shifting one sample, take the sum, then I can say Yn is equal to L by W0 into p equal to minus infinity to infinity, okay, 1 by n x of PL k e to the power j 2 pi by n into nk. This is the synthesis equation. So above equation, what is the constant imposed by the OLA method? It requires that the sum of all synthesis window obtained by siding Wn with L point increment to added up a constant. So I can say this one, sum of all analysis window which is shifted by a L sample must be give a constant. What is that? That means that I can say sum of all analysis window. So suppose this is my n, number of sample. So this is my first window. Let's it is shifted by L. The second window will be here 2L. So sum of all analysis window shifted by time dissemination factor must give me a constant, which is nothing but the WPL minus n should be equal to some constant. Okay. If it is that, what it is defined? So if it is WPL minus n is equal to constant, that means this finite bandwidth. So OLA method, it is shown that this constant is satisfied for all finite bandwidth analysis windows whose maximum frequency is 2 pi by L. This is possible when, if I take this is my analysis window and this is omega c, okay, omega c. So this omega c frequency whose maximum frequency is less than 2 pi by L, and this is 2 pi by L. So omega c must be less than equal to 2 pi by L. So FBS method, what I said, NW must be greater than or equal to at least n. Okay, sorry, greater than or equal to n, if in that case there is a special constant that n must be plus minus n, like that way, because that is also the relaxation is possible. Here also relaxation is possible, but in that case this w omega minus 2 pi by L must be 0. Here all should be 0. It cannot be any value at omega equal to 2 pi by k by L, must be 0. Okay. So, it doesn't matter if omega c is greater than 2 pi by L, then I have to ensure at every omega 2 pi by k 2 pi by L it should be 0. Okay. So, if I summarize FBS method, the constraint is this one, which define me the size length of the analysis window must be less than the number of analysis channel, and OLA method define a constant which omega c, the bandwidth of the analysis window must be less than 2 pi by n, 2 pi by n. Okay. Okay, this I will come later on. So, time frequency sampling, which is very important fact. Why we are doing that FBS method and OLA method? That I have to know, I don't want that, I want to suppose this is my requirement, I have a signal, I cannot take whole signal at a time and analyze its frequency domain and do some modification in frequency domain and take the inverse to get the time domain signal. This is not possible because the signal is non-stationary, some part is modified. So, what I say, I want to take part of the signal and analyze it in frequency domain and do some modification, take the inverse transform to get the signal back. Next, take the next portion, next portion. So, I want to know how much amount of shifting of this sliding is possible. It is generally it is possible if I slide the analysis window once every sample, but which is very time consuming and also time complexity, because if I have a 4800 sample, then 800 times I have to analyze the STFT. So, I want maximum allowable shifting so that I can recover the signal from the inverse transform, and also what kind of window I should use so that I know x of n omega for every omega. So, what will be the bandwidth of the analysis window and what will be the shifting dissemination in time. So, analysis window is non-zero, it is a finite length NW. So, temporal dissemination factor is L is must be less than the length of the analysis window, that we have already said. If it is greater than, then I know I miss the signal. Okay. And number of that 2 pi by NW must be greater less than the number of channel bandwidth. Okay. This is we know. So, considering window short time signal, Fn omega is equal to omega Wn into Xn, and x of n omega Fourier transform of Xn, analysis window is Nw. So, Fourier transform point of view, reconstruction of Fn omega, Fnm from Xnk require the frequency sampling at least 2 pi by Nw. So, length of the analysis, length frequency sampling. So, length of the DFT which define me 2 pi by n must be at least 2 pi by Nw, and for time domain viewpoint the dissemination factor L required to meet the Nyquist criteria, which means that omega c the cutoff frequency, or you can say the bandwidth omega c, the bandwidth L must be less than equal to 2 pi by omega c. Okay. So, I can say L is must be equal to 2 pi by omega c, and I have to choose n so that 2 pi by n, frequency sampling at least must be greater than or equal to 2 pi by nw. Nw is the length of the window. So, now I take an example. So, let us window length is nw, let us take window length is nw. So, temporal discrimination factor L must be equal to nw less than nw, and L must be equal to 2 pi by omega c, and 2 pi by n must be greater than 2 pi by nw. Okay. So, suppose take the example, okay, there is a called rectangular window, the length of the rectangular window is nw. Okay. You know, if it is a rectangular window, then what is the frequency domain representation of rectangular window? Is nothing but a sinc function. So, a sinc function, if this is omega c, this is minus omega c, this is plus omega c. Okay. So, now what is bandwidth? Is nothing but a plus minus omega c to plus omega c, which is nothing but a 2 pi by L, 2 pi by nw. So, I can say 2 pi by nw minus 2 plus 2 pi by nw. This is the bandwidth. So, Lw shifting discrimination in time must be equal to 2 pi by omega c. So, it is nothing but a 2 pi by, let us bandwidth b. So, it is nothing but a nw divided by 2. So, I can say 50% overlap is possible. L maximum 50% shifting is possible if it is rectangular window. Okay. We will discuss next class, we will discuss others window. Okay. Okay. Thank you.